Hello everyone, Luco is here once again, like every week, and today I hope we will finally start to have a cluster to work with. What I mean by that is that I plan and I'm fairly confident that I will achieve my objective for this stream. I plan to deploy Kubernetes finally. And just Kubernetes, I don't think I will be able to have time to actually go in depth about deploying some service on it. But I do plan to achieve at least that. And then maybe next week we can start to work on it, and maybe we can find out that I may need to deploy Kubernetes in a different way, as there are countless of pieces that can be put together, and I will start from a basic configuration. Going forward, I may find out that I need a more customized configuration. I may need something different than the most basic thing possible. So I want to say let's get right into it. And my usual notes about last week. I did not add, as previously I had this mermaid graph. I didn't add it in here on purpose. I don't think it's needed right now, at least not this. It will be the same for a while. These are done. I don't need to continue to talk about them, whereas this is what I'm working on. I will probably work on a new graph, mermaid graph, that will, how to say, will be about Kubernetes, but first we need to have something, and a Kubernetes cluster is that something that we need. So let's get right into it, and let's get right into it is by using this fairly old, almost 4 years old post from this Carmine Zaccagnino, that is a fellow Italian guy, so thank you, Carmine. And I will try to adapt what he has done to my own underlying infrastructure, let's say. He uses FCOS as well, so I will need very little adaptations, I have a feeling. And I will also mention right away in my notes about this. So first of all is taking let me think. Example. This will do. Taking from this example. Carmine. to properly to attempt to deploy a basic Kubernetes infrastructure. And that means that at the end I will do this. Perfect. So let's see what we need to change. This is the control plane, and indeed, as you can see, there are some different things, but not many. I need to create some configuration file, it seems, and I may need to change this version. But the rest should be alright. A yum repository, yum? Yeah, yum repository for I checked the last time, but I didn't write it in the note, but basically I do remember that Kube ADM is available, but I think the other two aren't. So the Kubernetes repo, I guess, will work only for these. I will check if maybe I need to change the URL. Net filter, what is this? Setting kernel parameter required by kubelet. Okay, that's totally alright. And this I don't need because I already have everything set up. I like this. I don't really. BR-net filter. First automatic loading of BR-net filter on startup. I don't know what this is, to be honest. Yeah, this is unlimited, but let's work on this first. So, storage, I will need to add a couple of files. All of this, basically. Okay. Cut and this netbed repo will go there. And let's go and do it after this. So I guess I can do it like this. Stuff. And I can add these things. Let's see if it breaks. It didn't, apart from this. And of course I want some more. Space myself. And it would seem to be alright. Now, what do I need to do? Create your latest version. And this is useful, but I will check it in another moment. This is made currently, but create or latest version 135.2. It seems so. That is what I write in here. I don't know, and that means that I need to search a little bit, maybe near. And this would be the setup, TCT, contract worker knowledge, QoS version. I don't remember, I saw it previously and I don't remember where it is. Action environment, policies, container runtimes. Okay, create on. Install, follow the install, create install instruction. Thank you, it's useful. But yes, it seems that the version should be tied to the version of. Perfect. So in here it is 1.35. And did I miss something? Files. This is a DNF module. DNF module. In theory, I should be back. In theory, I should be back. And maybe now it will be a slightly bit better situation. Starling, enabling. That's in the system advanced. Removing modular filtering conflicts. I'm trying to understand the words. Oh, wait. Building modules. For building modules. How to build DNF modules. I don't need to know it all. I need to know it a little bit. And this is not helping at all. To create a DNF module, sign the Fedora based system. DNF modularity, managing software with the DNF tool. Yes, maybe. Feedback, software management, no, yeah, this is not for my own operating system, but maybe package. Module setter PM package that represents a component. A typical module contains the following packet types. configuring DNF, search, maybe, not really. CoreOS in the modules locally. No, I don't want to build. DNF module syntax. This defining module. Oh Jesus! I mean. Searching the wrong thing? I don't know. Anyways, let's hope this is correct because I have no idea if it is. Anyways, done that, we can go into the Kubernetes repository. Kube repository. Begin. Fedora Kubernetes packages. Look at this. Look at this. Way different from what was there. So definitely this got to change. Core stable V135 RPM. Okay, and GPG key. This exclude complete. Okay, this I'm not certain, but let's do it like this, and let's substitute this stuff. This is not something I like, but let's do it like this. And let's hope it will fit correctly. No, not GPG check, only GPG check and enabled. Perfect. Automatic loading of BRNet filter. Let's hope it's correct and it's needed and it's right. And same for this because NetBridge, NFCall, tables, and there we go. Okay, and that means that I now need to take this stuff, copy it, save it, go in here, and do this, which in theory is correct. Tree. And worker. Perfect. Now I need to go through the recreation of the ignition files, and then I can recreate the virtual machines, which will be fun. I can do the OpenTofu destroy and then the OpenTofu create. I don't have a map and a map cut for FirewallD, but FirewallD is not needed. For the time being, I will not modify and add a map and map cut for the time being. I may change my mind later and install them, I guess. By the way, these are just added in the repo. There is no installation, as far as I can see. Okay, let me see again. And then it gives me the installation. The first one, which means custom control plane, install Creo, and require tools to create and manage the cluster with. The nodes only Creo runtime, Kubernetes, and Kube ADM are needed, and they can be installed with. After reboot, whatever. Okay, so what do we do? It's okay not installing for this time. Later on, maybe we'll install as well the packages needed. At the same time, I have 3 control planes. At least I plan to have 3 control planes. Therefore, I will need to install everything on the control planes, as far as I understood. This is not needed, and we will see. I need this. I don't need this. And yeah, control planes. Certificates, configure load pass, create multiple control planes for availability, should not be limited to single machine. If the control plane services are run by an init service such as systemd, each service should run on at least 3 machines. However, running control planes services as pods in Kubernetes ensures that the replicated number of services that you request will always be available. The scheduler should be fault tolerant, but not entirely available. Some development tools set up a Rust consensus algorithm to do leader election of Kubernetes services. If the primary goes away, another service elects itself and take over takes over, maybe? Yeah, maybe. Yeah, this I don't know. This definitely no, this I don't know, but anyways. Okay, let's start. So let's start. It means documents and cluster and Fedora CoreOS definitions, and in here we have all the various things. Pretty fast. Okay. We do the same with worker 1, and then we go with the control plane. Two. Okay, so now the snippets are ready. What I can do now is this. Interior place. And now I need to go towards the tofu plan. Minus this try minus out test, I think. Circle battery. And just to be certain, I mean, I can recreate everything whenever I want. I don't care if I destroy things. That's the whole point of the few weeks of work that I did previously. So we are here, we have everything. I should stay with the router on. Apply test. Let me see. Perfect. And now I will go like this and like this. It will take its time. I'm not in a rush. In the meantime, I will drink a little bit. Yeah. It is kind of interesting that the order is not really correct. So I would expect 100 to be control plane 1, 101 control plane 2, and so on and so forth. But it isn't. To be fair, I don't give it as a variable, nor do I give it as a thing to do, basically. So I don't really care about that detail, and yet it's, I don't want to say annoying, but I can notice it right away. Yeah, that's an issue I need to live with. Whenever I look at something, I first see the flaw, and then I see whatever else there is. and I need to work hard to avoid being stuck at seeing the flaw as it being the worst kind of thing possible, which is not always easy, but what can I say? The way my mind works is just the way it works. I can just live with it, not really change it completely. I can change how I behave, maybe, but not really how the brain elaborates things. I think this machine already installed Netbird. So if I go like this, Sage 101, Net, yeah, perfect. And at the same time, if I go RPM OS3, search for Kube, maybe I will find, Jesus, I will find too much stuff. Kube CTR, and I have it, and Kubernetes, and I have it. Nice, nice, nice. Now, let's go back to what they did. I don't need this, I guess. Set the host name, I already did. And I don't like mode 1, I have a slightly better one. I need to install, or better, I need to connect to all the VMs. 1, 2, 1, 3. What was it? 111 and 112. Yes. Perfect. And they are clones of the others. So this is for the control planes, and this is for the workers, as far as I understood. So RPM-3 install and what do we install? We install Kubernetes, we install Kube we install kubectl and create. Now, given the nature, we'll do this. In the worker, I will just install Kubernetes, kubectl, and create. So I will remove kubectl, right? Kubernetes, kubectl, create. Yeah. Once again. Oh, come on. I managed to do that in the wrong way. So we installed everything, it seems, and I can just reboot the root. And that is why I plan to actually install automatically like I did with Netbird. So I have a single root, everything is installed, and the machines are ready to be hosting the services that I want to host in them. In theory. But I will need to test it a little bit. We will do it together, of course. So now all the VMs need sudo systemctl enable now Creo and Kubernetes. Once again. What is it? Yeah, perfect. So everything is ready. Create a cluster and config. Yeah. Let's check first the Kubernetes documentation, because I have installed the installing container runtime, Clio, Kube ADM, Kubernetes and kubectl. Kube will not install or manage. For you, you need to ensure they match the version of the Kubernetes control plane. Oh. Let's see. Let me see. Where are you? Added. Okay. Creo 132. Creo tools 135. KubeADM, kubectl, Kubernetes. And this, not sure. I'm not sure. Ah, yeah, this I will not even check it out. Yeah, 135, but Creo. So Creo tools is 135 as well. Creo isn't. Container runtime version should match Kubernetes version. Let's see. So let's go to versioning, whatever. Container. There is nothing. Runtime. Kube proxy at the runtime must align with Kubernetes and cluster version to keep both networking and scheduling stable. Okay, so we may have an issue. We may have an issue. I don't know. S3 do I have 135? Why did it install the 132? I have no idea. I have no idea. I should have told it to install the specific version, I guess. Should rpm s3 install this. Let's see what happens. Error not step solver transaction over config package. I know. So I guess I should first remove the other one. Is it remove or uninstall? Remove. Uninstall. Oh. I think. Yeah, and now I can install in theory 135. Let's add some notes. I have to adjust the version of the container runtime. The repository and the test repository configuration. The transfer destroy went through as intended. The creation of the answer notice once again the user lines of the VM IPs and the VM names, which were already misaligned before. If you didn't notice, I did. Installing the packages. Requires be careful. I don't know if carefulness is a thing. Has to be careful as the creation installed was aligned with other pieces of the cluster. And maybe let's save in here the necessary command. Control create which version was it? 1.35 to make sure that the installed version is the correct one. And instead I can do this for worker, and let's remove kubectl. Perfect. Let's go into the other VMs and let's perform these steps. What? Look, let's do this and let's do this. That we will do the same thing with this. Perfect. And now reboot once again. Once again. Okay. Perfect. And we performed exactly this part. Configuring a C group driver. Both container runtime and kubelet have a property called C group driver, which is important for the management of C groups on Linux machines. Matching the container runtime and kubelet C group drivers is required, otherwise the kubelet process will fail. Okay, let's read this. This page explains how to configure the kubelet cgroup driver to match the container runtime cgroup driver for kubeadm clusters. Before you begin, you should be familiar with the Kubernetes container runtime requirements. I'm not that familiar, but yeah, okay, got it. Configuring the container runtime cgroup driver. The container runtimes page explains that the systemd driver is recommended for kubeadm based setups instead of the Kubernetes default cgroup fs driver, because kubeadm manages the kubelet as a systemd service. The page also provides details on how to set up a number of different container runtimes with the systemd driver by default. Okay, configuring the kubelet cgroup driver. Kube ADM allows you to pass a kubelet configuration structure during kube ADM init. This kubelet configuration can include the cgroup driver field, which controls the cgroup driver of the kubelet. A minimal example of configuring the field explicitly: kubeadmconfig.yaml, kind cluster configuration, API version this, Kubernetes version will be this, kubelet configuration, systemd. Such a configuration can then be passed to the kubeadm command. Note: kubeadm uses the same kubelet configuration for all nodes in the cluster. The kubelet configuration is stored in a config map object under the kube system namespace. Executing the subcommand init join and upgrade will result in kubeadm writing the kubelet configuration as a file under var lib kubelet config.yaml and passing it to the local node kubelet. On each node, kubeadm detects the CRI container runtime something socket and stores its details into the var lib kubelet instance config.yaml file. And when executing the init join or upgrade subcommands, kubeadm patches the container runtime endpoint value from this instance configuration into var lib kubelet config.yaml. Migrating to the systemd drivers, define the kubelet config map. Okay, so what do I need to do is creating this file kubeadm -config yaml.yaml, and this file should be created in here, in the first control plane, or yeah, I think so. But anyways, let's create it. config.sh. Okay. I don't have in my file calculator. Yeah, I have BI. It's not an issue. Let's write it as kubeadm config.yaml. So far so good. So far so good, apart from the fact that I need to change the Kubernetes version, and I hope that the API versions should be the latest. Kubernetes and kubeadm. Okay, let me see. This I finished basically, so I don't need it anymore. Is the latest version. Version will be 1 beta 4. Overview. Configuration will be 1 beta 4 135. So yeah, it's alright. configuration APIs. Okay, let's search for Kubernetes, maybe. Kubernetes configuration v1. So there is no v1 beta 1. No. Whereas the oh, come on. ADM, I guess. No. Kube ADM. What? Beta 3? What? Kube ADM configuration v1 beta 3. There's also v1 beta 4. Okay, this is the latest, I guess. Okay, I guess this should be correct. This should be correct. And I do plan to use systemd as as far as I understood, last week is meant to be working well with systemd. This I don't need it anymore. This is later. Okay, I think I can do this one. This I don't need it anymore. Creating another. Oh. Maybe I don't need this because I have this stacked. We said first steps for. I don't remember if I read it or. I think so because I remember the difference between stacked and external etcd. Yeah, probably because this, yes, stacked control plane, it control plane and blind. Oh, wait a minute. What the hell? Okay, this load balancer thing, what do I do? There it is. Create a load balancer for first steps for both methods. There are many configurations for load balancer. The following example is only one option. The cluster requirements may need a different configuration. Yeah, thank you. Create a Kube API server load balancer with a name that resolves to DNS. In a cloud environment, you should place your control plane behind the TCP forwarding load balancer. This load balancer distributes traffic to all heavy control plane nodes in its target list. The health check for an API server is a TCP check on the port the Kube API server listens on. It is not recommended to use an IP address directly in a cloud environment. The load balancer must be able to communicate with all control plane nodes on the API server port. It must also allow incoming traffic on its listening port. Make sure the address of the load balancer always matches the address of Kube ADM's control plane endpoint. Read option for software load balancing guide for more details. Nice. When setting up a cluster with more than one control plane, higher availability can be achieved by putting an API server instance behind a load balancer using the control plane endpoint option when running kubeadm init for the new cluster to use it. Of course, the load balancer itself should be highly available too. This is usually achieved by adding redundancy to the load balancer. In order to do so, a cluster of hosts managing a virtual IP is set up with each host running an instance of the load balancer, so that always the load balancer on the host currently holding the virtual IP will be used while the others are on standby. Some environments, like in data centers with dedicated load balancing components, this functionality may already be available. If it is not, user-managed load balancing can be used. In that case, some preparation is necessary before bootstrapping a cluster. Indeed it is. Since this is not a part of Kubernetes or kubeadm, this must be taken care of separately. In the following section, we give examples. Kubernetes and HAProxy. I did use HAProxy previously, so I may need to use that. Kubernetes. Let me see. Okay. Okay. I can run the load balancer as pods in the Kubernetes cluster somehow, and it's kind of breaking my mind. How do I run a pod? Run a service, I guess, inside a cluster that is not running yet. I'll be running on the control plane nodes if keep-alive-d and HAProxy will be running on the control plane nodes. They can be configured to run as static pods. All that is necessary here is placing respective manifest files in the etc Kubernetes manifest directory before bootstrapping the cluster. During the bootstrap process, Kubernetes will bring the processes up so that the cluster can use them while static. This is an elegant solution, in particular with the setup described under stacked control plane and etc nodes, which is the one I'm actually planning on using. For this setup, two manifest files need to be created in etc Kubernetes manifests. Create the directory first, which is something that I cannot do, I think. Sudo make dir. I think I cannot create this. Kubernetes manifests. No, it's already there. I don't need to create it. Yeah. Can I create the files in there? Vi etc Kubernetes manifests. Keep alive d.yaml. I will not even check what's written currently. Yeah, I thought so. I thought so. I thought so. I thought so. So I need to create these again in the butane configuration. Okay, not an issue. The managed first for HA proxy, and then not that here again a placeholder needs to be filled in. Needs to hold the same value as HA proxy C above. And okay, again, there are some placeholder in bash variables style to expand. The port through which Kubernetes will talk to the API server, produced by the API server instances. A symbolic name for the first load balancer API server hosts, a server address for the first load balancer API server hosts, additional server lines for each load balancer API server host. Nice. Nice, nice, nice. So I feel like this will be the first currently I wanna just see that it works. This load balancer can be and will be the single point of failure currently. Then I will add a second one again. Wait a minute, I can just spec containers, whatever. Volume mounts, volume status. I don't know if I can put a replica. Basically, we'll add these. Okay. Necessarily used with the version used in the example. Other version might work as well or may require changes in the configuration file with the services app. Now the Kubernetes cluster can be bootstrapped using Kube ADM init. I don't know, Kube VIP. Bootstrap the cluster control plane. Endpoint repo.mycluster.local. 8443. Yeah. So I got the reply that I wanted on the way in which these should be how to say, configured. But I will not use a DNS name, I will use an IP address, because the DNS name to be resolved requires DNS configuration, and I don't have a DNS server currently. I will have it in the future, but currently that's the limit. And the DNS server should be running inside the Kubernetes cluster too, which may be something that breaks my mind whenever I will try to do things. Anyways, I can do something like this. I just need to go in here and modify once again this stuff. And I will add a new one, but this time just for the control plane one, if I understood correctly. And Kubernetes stuff, load balance API server, and it would be wow. So it would be a path, and this path will be etc Kubernetes manifests, ecco correctly, yeah, and it will be keep like it, diciamo. Mode, and this will be interesting. I don't know the mode, so let's put 0644 and let's hope it's correct. Did I use override true for my stuff? No, I didn't. So let's not use it. Contents. Align. And I put all the stuff, which I don't know if it will keep the spacing correct. It didn't. It didn't. Perfect. Thank you. Kind goes directly here. Oh, yeah. Metadata goes directly with kind, but this. Oh. Spec is with the metadata. Containers is inside the spec. Yeah, okay. Oh, perfect. Name is in line with the image. Even resources. Security. security context as well, capabilities inside, but not that inside. I think the C is aligned. And in the P, yep. And same in here. This. Perfect. I truly hope this is aligned correctly, because it will be annoying if it isn't. Security context and volume mounts are the same. So, what did I do? I went to a different file. Okay. We were saying that this should be like this. And mount path is like this. Nice. Okay. Host networks is together with containers. Oh, okay. This. Volumes is the same. Almost. Path is there. This is like this. Okay. Thanks. And status is together with API version. And that means around here. Because this should be in line, so in theory I'm aligned. Okay. This was annoying, but I think I already have an idea of a better way to do this. Okay, this is for epoxy, so keep proxy, and we go basically like this. And here we go proxy. Mode will be like this. Contents inline. Okay, now I will do this for the sole reason that if I do this, everything is wrong. same time it's right, and I can just do this, and how much? L. In theory, this is perfectly ideal. At the same time, it seems that I messed up something up there. Did I? Yes, I did. Now it's fixed, I think. Containers and volume is the image volume. Wow, this is the image. Yeah. Host networks, volumes. Yeah. Okay, it looks good, and I still need to adjust what's written there. So let me see, this is all, what are these three? They don't seem to be variables. In here there was a variable, and it's written, so I'm fairly sure. I also needed to create this, but will it be in that folder? Okay, let's see. Proxy in Fedora CoreOS. Nice. Yeah, I already did that. Automatic security provision confidence, the whatever some user provision Kubernetes cluster with. Yeah, something like this. Checkbox config file. Okay, it seems that I will try and see, basically. Check proxy config file. Okay, is it right? Yes, it is. So we will copy this. Oh, come on. Fuck. And this will be hproxy.config.gfg. Same kind of thing. I will copy it as is and paste it as is. and then I will be moving it like this. Check a9 to del. Okay, perfect. Perfect. Bind, and it is a port, and it will be, in this case I will use the same port used by the other example, and then I have these. Destination port, the port through which Kubernetes will talk to the API server, port used by the API server instances. The one down here, 8443, not that, destination port. The configuration for the Kube ATM init needs to be done to use the port for the API server, assuming that in cluster port is used for advanced API server, and with the oh Jesus, API server destination port. Okay, it's correct, 8443. Let's use that. Let's not think about it. The port used by the API server instances. Would it be 6443 in this case? I hope so. And this one is symbolic name for the first balance API servers. General address for the host for the 268.1.11 if I recall correctly, and in here we put balancer 1. Okay, so in theory, the port in here should be the same. 843. Are we sure? Search port. Check verify none. I'm not certain. The port used by the API server instances. The port through which Kubernetes will talk to the API server. I think so. I think so. But let's search really quickly. So if I do this, gproxy Kubernetes APIs. I have a video in here. I can bind Okay, let's use 6443. I thought it was needed, but if it isn't, I won't create any kind of issue for myself. This was the question. Wait a minute. Look, let's try this. And let's see what happens. Oh yeah, I'm really caring a lot about the best viewers. And what is happening in here? Go figure. Come on. I want a quick look. Let me see if I can find what I'm searching. Okay, wait a minute. 81 is Broadgate as master 1, and it has an HA proxy load balancer that is 187. In my case, white one is both one control plane and the HA proxy load balancer. Let me see, control plane nodes, yeah, maybe having it a little bit bigger is better. Yeah, that seems to be what I'm doing. Yes, okay. Only that LB1 is inside master 1 in my case. So it's slightly different, but I want to see the configuration. Yeah, thank you, but let me see. Yeah, you are installing, you are doing all kinds of things. The configuration of the HA proxy would be nice. Duplicate, Kubernetes, whatever. Where is the HA proxy? It's again, yeah, okay. HA proxy stuff, maybe. Yeah, okay. Okay, bind and 6443. Down there, I could put the IP, but it's okay currently. Bind anything to 6443 in my opinion. I don't mind. and under 6443 as well with the, okay, so it should be correct what I've done. Then manifest, yeah, whatever. I think that's good enough. I think that's good enough. So this is good enough. And I have a single server. No, I have more servers. Let's go back to the configuration of a chip proxy, because there it is. I misunderstood. Control plane 1. And then we go like this. And we go 3, 2, 2, 3. Right? Yeah. Different configuration, but I trust the configuration explained in a Kube ADM. It just wasn't as clear as I needed it to be, and I hope that there ain't an issue there. That video was useful, so thank you Automation Tools for helping out. Now this is correct. I hope that all the white spaces are not an issue with the configuration file that I'm trying to create. Let's remove them, as it won't be an issue. If I'm not correct, we'll get issues. It's okay, we'll figure it out. So I have the load balancing stuff in place. Now, in theory, I can finally deploy, remembering to use this as well as this, as well as upload sets. But wasn't there the need to create another thing? For begin, first step, did this. Make sure, and the first control node, test the connection. Point, load balance TNS, so 101 and 6443. That's right. Load certs and the other thing, but in here there was also another thing. No, init arguments. Yeah, guess I'm seeing things. I know it was in the guide. I was taking some of the configuration from. That is this one. Create this control plane, just like the following, using whatever. Yeah, in theory I don't need it. Oh, cluster configuration. Extra arguments. Okay, yeah. Instead of using the inline, they are using the YAML file for the configuration of the Kube ADM init. Instead I do it inline, basically. Okay, perfect. That's the difference. And I have this part in here, but first I need to recreate everything once again. I guess so. In which case I might as well add in here store netbird and install also the other stuff which is present in my notes, I guess. Okay, so wait a minute. To have multiple, what is it? Multiple, I think I will continue on next week, but we'll write down the notes. To have multiple control planes, nodes, there is a need to use a load balancer for the API server. This can run in the Kubernetes cluster that is being deployed, which is mind bending. I have added the configuration for the user job keep alive the LHA proxy to create this load balancer in the control plane 1.bu file. Given I need to deploy once again the VMs, I might as well install automatically also the packages that I have installed manually. Hence I will be modifying define the netbird config.sh file script to ensure to and also those packages next week. Next week. Perfect. Next week, because I'm tired and because I saw what time it is, a little bit of a shorter kind of stream, but things are like this. We are getting closer and closer. I didn't know about this load balancer thing, to be honest. Otherwise, I would have known that today wasn't the day, but I want to say that in theory we fixed it. We already have everything in place now. Next week I will just modify slightly the netbird -config.sh file. Currently just adding the packages to the list of packages to be installed. In the near future I will also rename the file because to be honest, if it doesn't install just netbird, it cannot it doesn't make sense to call it just netbird config. Apart from that, everything is going in the correct direction and I'm glad. So thank you for watching. See you next week. Look out. Bye.